So the last thing we're going to talk about today is the average rate of change for GP number 2. And for this question, I'm going to be referring back to the same graph that we used for GP number 1b. There's no need for you guys to draw it again or to print a second one unless you would like to do so. But you can just go ahead and flip back to GP number 1b to refer to that graph. Now, average rate of change is the same thing as the slope, basically between two given points. But the thing with a parabola, which is the graph of a quadratic, is that the slope between any 2 points is not constant. Whereas what we've seen with a line is that if you find the slope between any 2 points, whether it be from this point here to this point here, or from this point here to this point here, it's going to be constant, which means we're going up 1 over 2. So up 1/2, or the slope is 1/2, rise over run. Or if we were counting from this point here to this point here, that would be up 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 5 over 10 reduces to 1/2. So on a linear graph, you have a constant slope between any 2 points that are on the line. Now, again, on a parabola, that's not the case. So if you're looking at this parabola here, the slope or the average rate of change from this point here to this point here would be 1 over 1, which is just equal to 1. The slope from this point here to this point here would be up 1, 2, 3, 4 over 2. 4 over 2 would be an average rate of change of 2. From this point here to this point here, that's 4, 5, 6, 7, 8, 9 over 1, 2, 3, which would be an average rate of change of 3. Now, we can go from any point to any other point that is on the parabola. It's just a matter of which interval of the graph or what domain of the graph is specified. So what we're going to do here is find the average rate of change over the specified interval. So I'm going to give you two different scenarios to look at. Now, the interval or the domain that you're given is going to be an interval notation. So if I asked you to find the average rate of change over the interval from 0 to 4, what you have to do is you have to look at your graph to determine the coordinates of those points. Now, again, this is our domain. So this is just the x values of the points that we're looking at. So we're going to take that interval and we're going to break it apart into 2 separate points. So the first x value of the first point is 0, and the x value of the second point is 4. So on our graph, we have to find the point where x is 0. So x is 0 on the y-axis because we don't move left or right. So the point where x is 0 is at 0, 9. That is the point on the graph where x is 0. Now, every single point on the y-axis is where x equals 0, but none of these other numbers are actually on our parabola. The point 0,9 is the point on our parabola. So next we need to find the point where x is 4. So we go to where x is 4. We have to find that point on our parabola though. So down here, this right here is where x is 4. So the coordinates of that point are 4, -7. So these are the 2 points that we have to use to find our average rate of change, or what we've learned before as the slope. So recall from our review notes that to find the slope, we use slope formula, which is y2 minus y1 over x2 minus x1. Now, it is imperative that you guys show this work. It is not satisfactory for you to just count on the graph and tell me the slope from there. You have to show the work. So we have to use slope formula here. So this is x1, y1, this is x2, y2, and I'm going to take these values and I'm going to plug them into slope formula. So m is equal to -7 minus 4 divided by 4 minus 0. I'm sorry, not 4, 9. Goodness. -7 minus 9 over 4 minus 0. So -7 minus 9 gives us -16 divided by 4 minus 0, which is 4. And that gives us an average rate of change or a slope of -4. Now, what I want you to kind of think about logically is that if we were to draw a line between these 2 points, so we have a point at 0, 9, and we have a point at 4, -7, essentially we're looking for the slope of that line. But what I want you guys making sure that you're thinking about every single time you look at average rate of change is that line increasing or decreasing? So notice that this line here is decreasing as it goes to the right, which means that we should have a negative slope. And if we don't get that negative slope, then we've done something wrong that we need to go back and fix. All right, so let's do another one. Find the average rate of change over the interval from 2 to 7. So again, those are the x values. Now what I want you guys to try to do now is pause the video, try to work through this and see how you do. If you don't get it right, you can simply fix what's there, but go ahead, pause the video and give it a shot. Okay, so hopefully you have attempted this on your own. So remember that the interval specifies the x values of our 2 points. So the first x value is 2, the second x value is 7. So on our graph, we want to find the point on the parabola where x equals 2, which is right here at 2, -3. Then we want to go to the point where x is 7, which is here at 7, 2. Now again, if I draw a line between these 2 points here, it's increasing as it goes to the right, which means the slope that we get when we work through this should be a positive value. So we have x1, y1, y1, x1, x2, y2. We have y2 minus y1, so 2 minus a -3. Make sure you draw or write both of the negatives so you don't forget it. Divided by 7 minus 2. 2 minus a -3 is 2 plus 3, which is 5. 7 minus 2 is also 5, giving us an average rate of change of a positive 1, which we said it should be positive, so we did good. So the slope between those 2 points is a positive 1. Now, don't forget to answer your essential question now that we're done with the notes. I'll see you next time.